Hello everyone, my name is Bernie Gigas. I'm a Lake Ontario shoreline resident in Greece, New York. My wife and I moved to the shoreline in June of 2016, just before the flooding in 2017 and 19. And I became very interested in how Plan 2014 works and how it's impacted lake levels on Lake Ontario and why we have been flooded 2 out of the last 3 years. I'm a professional engineer registered in the state of New York, and most of my career have worked in fluids. So let me get into the slides here. This first slide is from Plan 2014 documents. There are 6 criteria that I picked out from all the documents that are available publicly that highlight what Plan 2014 was intended to accomplish. So the first one is that Plan 2014 was to provide all possible relief to riparians during high water periods. That's criterion H14, which I'm going to cover in quite a bit of detail later. The second one is that it was to better define and adequately protect all interests. That clearly has not worked out. We have not been adequately protected. Third is takes into consideration the more extreme water supplies. We've had extreme water supplies in 2017, actually somewhat in 2018 as well, in 2019, and the plan has failed to accomplish its stated goal. Then next, we have that we are to be at or above the high trigger levels per criterion H14 about 2% of the time. The reality is by the end of 2019, we're going to be closer to 25% of the time. There's obviously fine print in all of this that says, well, if you don't have a lot of water, then that's going to be the case, but hey, we have too much water. Those rules have not applied to everyone. They only apply to Lake Ontario. Next is most of the increase in damage to shore protection structures expected with Plan 2014 could be avoided by building these structures a few centimeters or inches higher. That's an absolute joke. If we build our shore protection structures a couple of inches higher, we'll still be flooded. We'll still be flooded every bit as much as we were in 2017 and 19. So that projection is completely wrong. And then lastly, to use the adaptive management strategy should conditions have changed enough such that the plan is no longer meeting its intended objectives. What that really says is there is an adaptive management process that is intended to be used if the plan does not meet its objectives, and I've just outlined that it doesn't, to change the plan and reflect the reality of what we're trying to deal with. So in short, Plan 2014 has not worked as advertised. It's not even close. This is a shot from the North Shore, pretty substantial flooding. This was not the objective. So the agenda for today, 3 major points. It's pretty technical. There's a lot of numbers in this, and I apologize for that. But it's important to understand how the plan works and how the rules in the plan cause the high water that we've experienced. The first one is Plan 2014 F limits. That covers downstream riparians, primarily Montreal. I'm going to refer to the F limit often as Montreal. Then there's the Plan 2014 L limit that speaks to navigation, and navigation here refers to both commercial and private navigation. And then lastly, I have a forecast of where the lake is going to be on January 1, 2020. I put this forecast together July 1st of this year, and what the potential consequences of that are for 2020. How is plan outflow determined? Per Plan 2014, the outflow from Lake Ontario is calculated using something called rule curves. And these flows depend on the prior 52-week supply of water and the lake level. So from the 52-week prior supply of water, which is called net total supply, NTS, that number is taken, and from that you calculate what the outflow should be. Under high water supply, which is what we currently have, you then also calculate what should be the flow per F limit, again that's Montreal, and what should be the flow per L limit for navigation. And you take the lowest of those 3 numbers, and there's your outflow number. The reality is, in most of 2017 to 19, we've been operating per either the F limit or the L limit, not per the rule curves, which means the plan is driving us completely. A little bit of geography. This is obvious to most everybody, but I'll cover it anyway. So we have Lake Ontario right here. We have the Moses-Saunders Dam. on the St. Lawrence Seaway, which flows from Lake Ontario all the way into the Atlantic. And then we have the Ottawa River in red. And the Ottawa River comes from the border between Ontario and Quebec, flows via Ottawa, and then joins the St. Lawrence Seaway in Montreal. One question, of course, would be, well, the Ottawa River is so far down from Lake Ontario, how is that possibly relevant? Well, I'll explain how that works. The Plant 2014 F limits are designed to provide a balanced flooding upstream, which is Lake Ontario, and downstream, Montreal, and past Montreal, of the Moses-Saunders Dam, primarily in cases of high Ottawa River flow in spring. So let's get into the details of that. This is 2019 data. This is actual data, not projected data. The black line up here, this is Lake Ontario outflow. On this axis right here is plotted the flow rate out of Lake Ontario in cubic meters per second. The red line is the Ottawa River on the same axis. So 1,000 cubic meters per second. And you can see that the Ottawa River starts relatively slow in spring, or in winter rather, and then in spring, the Ottawa River crested very, very high. So the flow at that point in time is as big as the flow coming through the St. Lawrence. Now, when you take a look at the Lake Ontario outflow, the Lake Ontario outflow is throttled back, and this is the beginning of April of 2019. Lake Ontario outflow is throttled back just when the Ottawa River crests, and that's done to keep Montreal from flooding. Not an unreasonable point, but the way it's applied is not fair. This is a plot of what would happen without the F limit protecting Montreal and the lower St. Lawrence River. The orange line is Lake Ontario. The yellow line is Montreal. Technically the lake just before Montreal. So without the F limit and just following the rule curves and the navigation limits, Lake Ontario would have peaked on June 26, 2019 at 247.75 feet. Still high, but not the dramatic flooding that we experienced in 2019. And the point there is that when the IJC, when the folks at the IJC talk about, well, we've got a lot of water, it's Lake Erie, it's rainfall, that's partially true. That level would have been 247.75, not 249.08. The extra foot, 1.4 feet or even 1.5 feet, really comes from Montreal. Now, without the F limit protecting Montreal, Montreal would have finished at 75.8 feet. That's pretty high. This blue line that's in the middle of the slide is the equal pain point. For Lake Ontario, that's 248.03 feet, and for Montreal, that's 73.75 feet. That's where the plan specifically states that's your equal shared pain point. That's where we're both flooded equally. So without the F limit, Lake Ontario would have stayed below that upper limit, and Montreal would have been above the upper limit. The F limit clearly serves a purpose. Now, with the F limit, and this is what actually happened, so this is real data now. Here's Lake Ontario, and we finished at 249.05 feet, and that happened on the 7th of June. And Montreal, same data, approaches the equal shared pain point and is held hard at that number. Montreal has an upper limit of 73.75 feet that, per plan, cannot be exceeded. It is a hard upper limit. Lake Ontario has no such upper limit. We can exceed our 248.03 feet to any height that is required to keep Montreal protected. So here's side by side. On the left-hand side, what actually happened with the F limit. On the right-hand side, what would have happened without the F limit. So what's pretty clear from this is that the F limit flips the flooding from Montreal to Lake Ontario. Summarizing the F limit. The F limit is in place to protect Montreal from flooding primarily during Ottawa River spring melt. The Ottawa River is entirely in Canada and downstream of the Moses-Saunders Dam. I agree that the concept of a shared floodplain is appropriate. Plan 2014 identifies the upper limit of the shared pain at 248.03 feet, for Lake Ontario and 73.75 feet for Montreal. There's a good reason to have limits like this. Nobody wants to drown out the lower river as well. I get that. However, once Montreal reaches 73.75 feet, the flood damage stops being shared. And Lake Ontario and the upper St. Lawrence River absorb all additional water independent of the source. In 2019, the source of the additional water was mostly the Ottawa River. And I presented this to the senior staff at the IJC. People questioned whether my numbers were right, and they eventually agreed that, yes, the Ottawa River added 1.5 feet of water to Lake Ontario this year. So when Pierre Belland says in a TV interview that was aired not long ago that we have no way of holding water in the lake, he is completely wrong, and he's not telling you the whole story. The story is that we are purposely holding water in Lake Ontario to keep Montreal dry. Concept is good, but the execution is not fair. It's not equitable. Okay, so that's the F limit. Now we'll talk about the L limit for navigation. Plan 2014 L limits are designed to maintain St. Lawrence River water flow velocities safe for ship navigation purposes. And again, the navigation limit here applies to both commercial navigation and private boats, yachts, sailboats, what have you. The L limits extend Lake Ontario flooding and prevents year-end Lake Ontario level reduction necessary to minimize risk of repeat flooding for the following year. The L limits apply from April 1 to December 31st. There's an L limit that's technically in place for January 1 to March 31st, but that number really doesn't apply. It's 11,500 cubic meters per second, not relevant. So we're dealing with first creating a flood by the F limit and then extending it by the L limit. And let me get into the details there. In the event that Lake Ontario water levels reach or exceed high levels, the works in the International Rapids section, that's the Moses-Saunders Dam, shall be operated to provide all possible relief to the riparian owners upstream and downstream. That's a direct quote from Plan 2014. No carve-out is made for navigation during high water periods, but in the very same clause, clause H14, there is a carve-out for navigation during low water. They didn't forget to put this in. They didn't put it in on purpose. Criterion H14 has to be read as protecting riparian rights upstream and downstream of the dam when the water levels exceed trigger levels, as we've had. During extended periods in 2017 and 2019, when Lake Ontario levels exceeded the defined trigger levels, the IJC has limited Lake Ontario outflow with no or only minor concessions to the L limit. This is an apparent violation of Plan 2014 Criterion H14 and extends the duration of the flooding on Lake Ontario. Now, the reason I use the word apparent violation is because I'm an engineer, not a lawyer. However, you saw in the prior slide what it literally says in Plan 2014, and I will leave it to you to decide whether you think that's an apparent violation or a violation. So Criterion H14 apparent violation in 2017. This is all actual data. And this is the most complicated plot in the presentation. I'll cover it in some detail. The orange line, once again, is Lake Ontario. That's the level in Lake Ontario, plotted on this side. The blue line right here, that's Criterion H14 trigger level. So that trigger level varies throughout the year. Now remember, when we're above the trigger level, we're supposed to let out enough water, or as much water as we can, technically, to protect riparian rights. The blue line is Lake Ontario actual outflow, the dark blue line, and the red line is the navigation limit. So what you'll see in here is that in this yellow area right here, between the 8th of June to the 27th of August, we were not operating per the F limit. Montreal was already down. But we were getting very little, if any, relief as dictated by criterion H14 to get the water out of the lake. So in 2017, the L limit was applied for 81 days in violation, or apparent violation, of criterion H14. Looking at this again for now 2019, same plot, Lake Ontario in orange, criterion H14 in blue, light blue, Lake Ontario actual in dark blue, and navigation L limit in red. From the 9th of May, which is here, through the 7th of June, we were operating per the F limit. Can't do anything there. But starting on 8th of June, Montreal was no longer at the upper limit of 73.75 feet, and we started violating, or apparently violating, criterion H14, and that is still current today. And we're very likely going to be violating criterion H14 all the way through November 1st, which means this year, 146 days of apparent violation of criterion H14. And this is relevant because it keeps us from getting the water out of the lake after the flooding so that we don't have the same thing happen again next year. And the IJC and the board that regulates the St. Lawrence River is not taking sufficient action to get the water level down sufficiently. So here's my forecast for the end of the year. This goes from January 1, 2017 and through December 31st, 2019. There are 3 lines on this. There is a dark blue line, which is my calculated water level in Lake Ontario. There is a red line, that is the actual Lake Ontario level. And then there is a discontinuous light blue line, which is the actual criterion H14, now not smoothed out. So this is criterion H14, the trigger level. And the blue and the red lines show my calculated versus the actual lake level. There's 2 things that come out of this and why I want to show this plot. If the blue line, the dark blue line and the dark red line are on top of each other, that means that 1, my math is right, and 2, it means that the IJC data is good. And that's an important point because I've heard people argue that the IJC is not giving us the true numbers. The model says that the numbers they're giving us are good. They're excellent data. We just don't like the data that they're presenting. So this black line was July 1st. That's when I made a forecast. And that forecast is the blue line through the end of the year, and the red line tracks what's been happening since July 1st. And so again, the blue line and the red line are very close to each other. So my forecast for July 1st, today is October 23rd, and what we're seeing here is that the forecast is really pretty good so far, a little over 3 months into it. Okay, what does that forecast tell us? Well, that forecast tells us that at the end of this year, on December 31st, 2019, we will be at 245.9 feet. That's higher than the target level that Plan 2014 has, and it is also higher than the level that we went into January 1 of 2018 and January 1, 2019, which means my forecast says we'll be at a higher level next year than we started this year. Okay, what does that mean? Is that a big deal? Well, yeah, it is. So here is the incoming level for 2017 at 244.36, incoming level 2018, 245.28, incoming level 2019, 245.34. Will very likely be 245.9 feet plus or minus 0.2 feet at the end of this year. The white numbers in these blue bars are the lake level rise from January 1 to the peak of that year. So in 2017, 4.59 feet, in 2018, 1.77 feet, and that's fairly average, and then 3.74 feet this year. Which means that if we're 245.9 at the end of this year, and we have another wet spring in 2020 like we had in 2017 or 19, 250 feet for next year is foreseeable. That is not a forecast, that is not a prediction, But in an engineering sense, it's foreseeable and we should be planning for it. We should be taking action to prevent that. And we're not. IJC is not taking the necessary action. Even if we have an average year of 1.8 feet, we'll be at 247.7 to 247.8 feet next year. That's already flood stage. Even with an average year, we will very likely be very wet again next year because the IJC is not taking action. The assumptions in the forecast, because that's a fair question. The assumptions in the forecast are that Lake Erie flow into Lake Ontario will continue to be high between now and the end of the year. That's not much of a forecast. Lake Erie is high. The other upper Great Lakes are also high. We're going to continue to have very high inflow into Lake Ontario from Lake Erie. The next one was that precipitation from July to December 2019 is going to behave similar as it did in 2017 and 2018. Because precipitation is only about 15% of the incoming water, that assumption is fairly safe to make and has turned out to be reasonably accurate as well. And then finally, Lake Ontario outflows will be capped at the navigation limit plus 200 cubic meters per second. That's something that the IJC announced on July 25th, and they have followed those rules. They've certainly done that. But those are the three assumptions. I need to make no further assumptions to get to 245.9 feet. And the recent forecast from the Army Corps of Engineers is fairly close to this number as well. Okay, so what does 250 feet look like? And here are just some snapshots from various areas near Sodus, New York, right on the south shore of Lake Ontario. This tool exists on the internet. You can look up Lake Ontario inundation maps and plot your own house on this. So anything in yellow is underwater at 250 feet for Lake Ontario. So this is Pulteneyville, here's the harbor jetty, and here's the Pulteneyville Harbor Grill. Pretty wet. Not bad. This is Sodus, and this is bad. This is Gregg Street. That entire peninsula is underwater at 250 feet. I've been on Gregg Street. I've measured the break walls there, and this colorization is accurate. It may not be completely accurate within a few inches, but certainly that peninsula is underwater at 250 feet. Leroy Island, there's a marina down here on the bottom right-hand corner. I'll show that again in a second. That's underwater. Crescent Beach, which is this region up here, will be underwater as well. So here's Crescent Beach in a bit more detail. All these houses over here, all these cottages are completely underwater. They're washed over. And mind you, these plots right here assume flat water, no wind. So you need to add waves on top of that. So if you add 3-foot waves on top of this, you can imagine what that will look like next year. 250 feet is a disaster. Leroy Island. So here's the marina I talked about earlier. This is Fowler's Marina. And it's questionable whether the bridge will even be passable. This is Gregg Street. This is the peninsula I was talking about before. This entire peninsula will be inundated, will be underwater. And it won't be inundated for a day or two or a week or two. No, it'll be underwater for 3 months, which means a lot of these houses will need to be torn down. Maybe not all of them, but certainly a lot of them. And there's a Sunoco gas station in Sodus that at 250 feet is actually underwater. So much for the environmentally sound Plan 2014. So now we get into some of the conclusions of the presentation. Lake Ontario rose 3.74 feet from January 1, 2019 through June 6, 2019. If the level had been lowered to 244.25 feet on December 31st, 2018, we would not have had widespread flooding. We would have been at roughly 248 feet, which is still high, but not the catastrophic flooding of 249 feet that we experienced this year. A good plan with an effective year-end target, and one that is actually followed, would have minimized flooding. Again, not avoided flooding, but minimized it. And then again, the IJC is operating Plan 2014 in apparent violation of Criterion H14, which keeps us from getting to 244.25 feet. In fact, it keeps us from getting to 245.4 feet as the plan currently suggests. Approximately 55%, 1.1 feet of water being held on Lake Ontario is due to the F limit in 2019 over 2018. And I use 2018 as a reference point here because 2018 is the one year where Plan 2014 worked beautifully. The Ottawa River crest was more average, not as extreme as it was in 2017 and 19, and it forms a good point of where the plan works. So the plan can work. It just does not accommodate extreme water supplies, which is one of the primary things that Plan 2014 was supposed to address. So 55% of the increase, 1.1 feet, came from the F limit. 45% of the increase over 2018 came from Lake Erie and from rainfall. The reason I bring this up here is when the IJC folks suggest that the flooding on Lake Ontario is because of rainfall and Lake Erie inflow, they are telling you less than half the truth. They are not talking about how much of the impact comes from the F limit in Montreal and the lower St. Lawrence River. So in effect, the Lake Ontario shoreline, both north and south, and the upper St. Lawrence River are paying for a Montreal and Quebec problem and shipping profits. Based on my justifiable forecast, Lake Ontario is projected to be 245.9 feet on January 1, 2020. If spring 2020 is similar to the spring of 2017 and 2019, 249.5 feet to 250 feet is foreseeable. That's between a half a foot and a full foot higher than we had this year. And we know how bad this year was. So there's a whole lot of text on this. I presented this to the IJC formally, and I wanted to make sure I had all the documentation in there. Focus on the red areas. Lake Ontario level should be no higher than 245.41 feet on December 31 at the end of a year. That's in the plan. That is not a hard upper limit, but that is the target that they're shooting for. One effective way of getting that, and this was done in July, was to increase the outflow from Lake Ontario by 500 cubic meters per second above the navigation limit, above the L limit. The IJC ignored that and put it at 200 cubic meters per second above the navigation limit, which is why we're not going to wind up with the poor protection that the plan provides us. No, we're going to have 245.9 feet at the end of the year, plus or minus 0.2. A target level of 245.41 feet at the end of the year has already shown not to work. 2019 showed that very clearly, because we were below that target, but we rose 3.75 feet and wound up at 249 on the lake. So the adaptive management clause in the plan says, if the plan's not working, change the plan. Well, let's do that, right? So let's change the year-end target under current conditions to 244.25 feet. If we do that, we will have reasonable protection. It won't be completely dry. We do have high water supplies, so the lake is going to be high. But we cannot accept continued flooding at 249 feet or above, as we've had this year and may potentially again have next year. So last specific recommendation, and this is to get the folks in the lower St. Lawrence River really on board with this. If the flooding is supposed to be shared between the lower river and the upper river, then we need to change the F limit, and we need to add at least 2 more tiers in the F limit and not have a hard limit at 73.75 feet, but actually bring that level up so that Montreal and the lower river isn't protected by a hard upper limit, and Lake Ontario has no limit. Then finally, the upper tiers of the L limit should be raised by 300 cubic meters per second. That gets us down faster than we currently are after high water events, and doesn't set us up for another flood the next year. So my recommendation there is a minimum of 300 cubic meters per second. Long-term solutions, Some of these are not as practical. All the prior solutions don't require any infrastructure changes. They just require administrative changes. Nobody needs to build anything. There's no construction, there's no money spent for infrastructure projects. They are just plan changes. These recommendations here are more fundamental. These will be expensive and take a lot more time, but also more permanent and provide a better solution long term. So the first one is, along with Montreal, the city of Ottawa is also flooding. If you take a look at the news reports in 2017 and 2019, the city of Ottawa is under a lot of water. They have a lot of flooding issues. So if we can find a way to control the Ottawa River upstream of the city of Ottawa, then that helps everybody. That helps the city of Ottawa, that helps Montreal, that helps the lower St. Lawrence River, the upper river, and Lake Ontario. That's the best solution, but probably also very difficult to implement. The next one is build a seasonal canal south of the St. Lawrence River to bypass Montreal, bypass the area that's really congested, where you really cannot get more water through right now. And what that does is allows, during high water events, allows more water to be let out of Lake Ontario without that impacting Montreal. Again, that's a civil engineering project, not simple, not cheap, and certainly not quick. So this concludes my presentation on my analysis of Plan 2014 and how it fails to meet the objectives laid out for it, and how it is working to keep Lake Ontario levels high and keep us from flooding again next year. Thank you for your time and listening, and good luck.